Hey everybody, Mr. Regan here, and hopefully up to this point you were able to explain to Sherman kind of where he went wrong in thinking about our birds and their bird beaks, more importantly, how different traits get passed down to different generations. That being said, Sherman obviously needs a little bit more help from time to time, and now we're going to be using a model to help Sherman visually understand what's going on with our bird population. And our model is a little different than we're used to. And we're going to go through some new features that we have that's going to pull in some big ideas like reproduction and such. And then we're obviously going to be dragging and dropping different bars to help predict and show Sherman what is going on. So let's take a look. If you notice, we have our modeling goal. We need to create a model to help explain to Sherman how the beak strength traits get passed down and how that can change the distribution of traits in a bird population. So we're looking at passing things down and changing the distribution. We are going to be using some new icons here, some old ones, but nonetheless, we're looking at this graph here at the start. And if you notice, according to our graph, we have the distribution, okay, at the higher side near the weak beak strength and lower at the strong strength with 9 and 10 not existing. And we notice down here in the environmental section that we're changing from soft seeds to tough seeds. So we know that if we have a weak beak, they're better at eating the soft seeds than those with the tough beaks. And the environment's going to change from soft to tough. So we have to figure out, obviously, which ones are more likely to survive and less likely to survive. And now we have some new icons that deal with who's more likely to have offspring, who's not. So let's take a look. Our new icons now, they used to be pluses and minuses. Now they're S plus and S minus, O plus and O minus. And notice we have some new colors here too. So the S pluses represent which distribution of our bird populations are more likely to survive. The S minus, similar to the minuses, which ones are less likely to survive. The O pluses, which ones are likely to have more offspring. And the O minuses, which ones are likely to have less offspring. So we know that anytime an organisms reproduce, they're very likely to pass on their traits to their offspring. So our goal would be to drag and drop all of these different icons that we see here onto our different graph. So we'll start by pulling all of these icons onto our starting population, and then we'll drag and drop our bars here to predict what's going to happen. So first and foremost, obviously we are dragging and dropping across the distribution. And we're looking to identify first which ones are more likely to survive, which ones are less likely to survive, thinking about adaptive traits. So you're going to drag and drop our pluses above some, our minuses above others, until you feel like you have the right traits identified for adaptive and non-adaptive. Notice I'm just randomly putting them in. You guys have to make sense of it. After that, we then have to figure out which ones are more likely to have offspring and which one are less likely to have offspring. Thinking about which ones may die and obviously not reproduce versus those that might survive and reproduce. We can put icons above other icons to show like, hey, these are not only more or less likely to survive, but they're more or less likely to have offspring. And you can do obviously the opposite or the same thing for others. So some might have double, some might have single. You can match them up more than one on different distribution bars. It's totally up to you. But you need to decide which of these bars represent birds that are more or less likely to survive and which of these bars represent birds that are more or less likely to have offspring. Once you're done placing your icons in the first graph, you're then going to predict in 50 generations, what would the distribution and variation look like? Are we going to have high variation? So we're going to have a lot of bars, okay? Are we going to have a low variation? Okay, so that means we have a low number of bars. So here I have a lot of bars. Maybe I need a low number of bars. Is my distribution going to be on the strong beak side? Okay, then my bars need to be over here. Is it going to be on the weak beak side, or is it going to be spread out? And then what distribution? Do I have to have a high amount or a low amount of different types? So remember, you grab your pink bar and you drag it up or down to show, oh, this has a low distribution, this has a high distribution, whatever works best. But notice, folks, you have to predict in 50 years, if we have only tough seeds in our environment, what would our population's distribution be like? Where would my bars be? How big or how small would they be? So that's how we use our new modeling icons here in the first graph. That's how we use our old modeling icons to predict with our bars in the second graph. If you have questions, obviously you're going to reach out to me. If you're somebody who puts your X in the yellow or red section when you get to the survey, reach out to me as well. Otherwise, good luck.